Greetings, Sainsman. Let's go ahead and get started on lesson 3.1. As we get into chapter 3, we're going to be discussing some relationships between angles. They're formed off of various sets of lines, including parallel lines, perpendicular lines. So there's some terminology that we need to address and make sure that we got some definitions that are down. First thing is going to be regarding parallel lines, which are coplanar lines that never intersect. So, oops, that's how you spell that. Intersect. So, think about this. So, if I have two lines, like railroad tracks, let me draw this a little bit better for you guys. I'm putting my little arrows on the end, showing that these extend infinitely. And these lines are going to go on, and they're never going to touch. All right? Next. Now, I want you guys to consider, still have a line. And is it possible to have lines, and again, you see this definition with parallel lines. Is it possible to have lines that never intersect but are non-coplanar? And it is, and what these are called skew lines. So think about this: when you have these skew lines, if you were to take the line that we have right here, all right, that you've drawn on your paper, take your pencil and if you were to punch through your paper, stab through your paper, but through that line, that would be you have a line that's in excuse me, but not touching this line, right? If I intersect this line, I've now made a whole new plane. Okay, so I have two intersecting lines and they do so in a plane, which we know. But if you were to stab through your paper with your pencil anywhere except for on that line, these are not on the same plane and these would be skew. Okay, I can demonstrate for you guys when you're coming to class as well. Next, we have intersecting lines. And that's pretty straightforward, which is just two lines that intersect in a plane at exactly one point. No matter what, when lines intersect each other, they touch each other, it happens in a plane. All right. And last but not least, we can have parallel planes. When we have two or more planes that do not intersect. So to visualize this, think about the paper that you have in front of you. If you were to float another piece of paper on top of it, that would be a parallel plane. All right. So next thing, I don't need you guys to write down. Give you guys a example, something from my life. I've shared with you guys, many of you, that I once upon a time lived in Colombia. And you get this in Colombia. You get this also some other cities across the world. San Diego is structured in parts and in places this way. It's a little bit more difficult because we have so many canyons, especially in the neighborhood where our school's at. That breaks this up. But when I lived in Colombia, there's the street system was interesting. They had this. You don't need to write this down again. So these that were going these streets right here that were going north south, they called these guys carreras, and they called these ones going east west. They called these calles, but they were all just streets, and they were all numbered. Okay, so I'd have street 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, and then let's say if I met here at Carrera 3 with Street 1, like the game Battleship, right? And I want to get all the way over to down here, okay? So the way that this is going to happen, obviously the straightest way for me to get there, I have to use the streets if I'm in a car, right? But it involves a lot of turning in order to get to where I'm going to go, okay? Or it's not going to be as short. It's going to be a little bit longer if I take this, kind of L shape all the way to get to my next destination. But wouldn't it be great if I was able to just kind of just like slash through there? Okay. So what they do have, and these also exist in places like Mexico City or even in London. And in Colombia, the word that they used, it's the same word in English as it is in Spanish. In Spanish, the word is transversal, but it's transversal in English. And what it is, it's a line that intersects two or more coplanar lines. Okay? So I'm going to go ahead and just kind of get rid of this part right here. So this is what we have. Don't really need to draw that little grid. This is just for example. I'm going to show you guys an example, a very specific example that we're going to see a lot of in this chapter. Okay. So when we draw, first of all, oh goodness gracious, I'm having a hard time making these lines. Anytime I have these lines, the way I'm going to mark parallel is that you guys have these little arrows that are also on the line. Okay. Now I'm going to draw in blue this guy, which is my transversal. And this specifically is a transversal, and we'll call it cutting two parallel lines. So this is going to be a scenario we're going to see over and over again, all right, time and time again. Once you guys consider this, so there's a lot of ways to look at these. So let's just draw some lines. Okay, nothing's marked parallel. All right, you have three lines. And the question being, think about what our definition was. And a transversal was a line that intersects two or more coplanar lines. So I have three lines here. I have line A, B, and C. And I want you guys to think about this. Which of these three lines, A, B, and C, and maybe somebody in our chat, we had a few more guys, but it looks like it fell off a little bit. And if there's anybody who's able to chime in and give you a shout out here, which of these lines is the transversal? Thinking about what that definition is, which of these three is the transversal? And the answer is all these lines are transversals, right? It's going to be intersecting two or more coplanar lines. Well, you don't see B and C intersect, but are they marked parallel? No. So at some point, you know, like way over here, these guys will intersect each other. You know, it's going to happen. In which case, B will intersect A and C, right? Because it intersects everything. So all three of these lines, A, B, and C, do intersect two lines. Okay, but it's easiest, especially for these next relationships that we have, to identify and to use the example where we have the parallels. Okay, so let's draw a diagram here. Again, let's draw these guys. And we'll have lines A, B, and C. And what we have here, let's do some notation. We have line A, and it's parallel with line B. Now, you guys see that little double slash? This double slash means parallel. Be interesting how many students ask me this in class what that is. So I just want to answer. We should know from our notes, right? I'll just direct you to the notes. And you guys will, when you hear that in class, you'll be able to see which of your classmates is not, you know, watching these videos the way that they're supposed to be. And of course, this is with transversal C. Now here, only C is going to be transversal because A and B are parallel, and we know this because we're working with such. Okay? Sometimes we see like a little thicker arrow. It's a little filled in arrow right there. And you can do it with or without that. So, first of all, let's talk about what the interior angles are versus what the exterior angles. All right, and I'm going to number these angles. You guys ready? 1, 2, 3. Oh, goodness. 3, 4, 5, 6, 7, and 8. All right. So, our interior angles, that's going to be what is inside or in between the two parallels. So I have I have 8 angles total. 4 are going to be interior, 4 are going to be exterior. Oh, quick questions. If two lines are parallel, can they ever intersect in a different dimension or perspective? I don't understand that. We're talking about if they're parallel, they won't intersect because they are in in order to be parallel, they have to be in the same plane. So the notion of this is where Euclid's postulate 5 does come up with regard to parallels, and it's something we'll discuss in class because that's where there's a departure in the field of geometry, and we can actually start talking about spherical geometry as well. But we're not doing that right now. Okay. Interior angles. We have angles of 1. Sorry, it's not 1. It's going to be these guys right here. These 4. They're inside. Angle 3, angle 4, angle 5, and angle 6. And then exterior, I have these 2 and these 2. Those are outside. So that's angles 1, 2, 7, and 8. Now there's 4 classifications. There's four ways for us to define angles. It's easiest, in my opinion, to see when we have parallels, but it doesn't need to have parallels in order for this to exist in those relationships for transversals. But again, I think it's simpler for me to explain in this scenario where you have the 2 parallel lines cut by a transversal. So we have what's called alternate interior. We have alternate exterior. We have consecutive interior. And we have corresponding angles. All right. So here we go. The alternate interior and alternate exterior. The way that we are going to explain this, first of all, to be an alternate interior, it has to be an interior angle. So only these 4, which we've already defined, 3, 4, 5, and 6, are going to be possible as my answers. Now, when it's alternating, it means it skips over or jumps over the transversal. So in this case, I have angles 3 and 6. These guys are going to be alternate interior. These guys are paired up together. Also, paired up together are going to be angles 4 and 5, right? Jumping over that transversal or alternating over it. Okay. Next, we'll have the exteriors 1, 2, 7, and 8, right? These guys and these guys, which we're going to have again jumping over the transversal C 1 and 8, as well as angles 2 and 7. Next, consecutive interior. Getting a question asking about 2-dimensional space, but then something with 3-dimensional space. And the question, it's in the chat right now. It's something I can address in class, but we are referring to 2-dimensional space. Okay, so that's kind of the long and the short of your question, but it's something we can address in class, and you can follow up with me there for further discussion. Okay, alternate interior and consecutive interior. Okay, so here's what I mean by that. Consecutive interior. Now we have 3 and 6, right? Now also interior would be 3 and 4, but guys, they already have a name. That's a linear pair, right? So it's going to have to be these 2 right here, 3 and 5. So they're on, you don't alternate over the transversal. So these are consecutive interior, which is going to be angles 3 and 5. Also, here, also both interiors, angles 4 and 6. Okay. And last but not least, we have the corresponding angles. Okay. One will be interior, one will be exterior. So it's what's going to correspond and formed off of the transversal on the parallels. Okay. It would be this. 2, 6. Okay. These guys will be consecutive corresponding. Next, angles 1 and 5. Next, angles 4 and 8. So every angle here is going to have an angle that corresponds with it. 2 and 6, 1 and 5, 4 and 8, 3 and 7. And then we should have one more there, right? 1 and 5, 2 and 4. Actually, no, that's all. I've listed all 8 angles. Okay. Last but not least, let's talk about perpendiculars. Okay. So here we go. 2 lines. And we have line L, have line J. Okay, and they are perpendicular. I have a right angle, and I have line L is perpendicular to line J. This upside down T means perpendicular. Okay, so when lines are perpendicular, means there is exactly one line that is perpendicular through L, okay? Which in this case is J. So there's only one that's going to exist that has the relationship of being perpendicular. When you have these intersecting lines, they intersect to form 4 right angles. And all those angles are congruent, which should make sense because they're all right angles, therefore they all have the measurement of 90, therefore they're all the same measurement, and therefore congruent. We'll talk more in class. You guys have the basics though, and you'll be able to start your assignment. All right. Good luck.